Hello guys, welcome to Solving Solutions on our channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to use ArcGIS Pro to get slope, right? Good now, to carry out slope analysis. Now we are having a link here that shows how slope works. It's a direct link from the ArcGIS Pro documentation. Slopes are represented in either percentages or in degree of slope, right? Good. So now for the degree of slope we have the theta. For the percentage we have rise over run multiplied by 100, right? Good. So now link to this documentation will be on the description section of this video, where you can go and have an exhaustive munch of the whole description as it has been stated. We have two methods, the planar method and the geodesic, right? Good, the geodesic method. So these are the two methods with which you can actually compute slope. So the link will be there, just access it and then read through. Now back to ArcGIS Pro, we have a digital elevation model which we have just worked on the symbology to, let's say, have a, okay, let's invert this. Good, so to have a better representation of the terrain. Now let's come to the analysis and then let's have the toolbox out. So we have the toolbox. We can now search for slope, right? Good. Now we are using the 3D analyst tool. Okay, that's the slope there, right? Good. Now if we still come back to the documentation, it only works when you have the special analyst license and then the 3D analyst license, right? Good. So that's when you can actually have access to the slope tool. We prefer having it expanded so that we can have the parameters showing better. Now let's put this out. The input raster will be the digital elevation model we have. Good. Now if you pay close attention, you are going to see that digital elevation model we have it as projected. Now the reason why we projected it, or the reason why we are using a projected DEM, okay, let's come to source and then the spatial reference. The reason why we are using a projected DEM, you can see the UTM zone 33 not, right? Good. So now that is where it falls, so that we can have unism in our Z factor. Good, which is this, right? Good. Now the Z factor is 1. If you look at the information here, there's a description of what the Z factor is. Let's just hover the mouse around it. Good. So now it's optional. However, the number of ground XY units is 1 surface Z unit. So if you read through, the Z factor adjusts the units of measure for the Z units. So if your X and Y are in lat and long and then you want to use a Z factor of 1, it might not really give you a better representation of what you want, because X and Y, your latitude and longitude, the units are not in meters, right? Good. So if you want your Z factor to be in meters, then your X and Y should also be in meters. Hence we used the projected DEM, right? Good. So now that's a very important part of the tutorial you need to understand. Now let's leave the output raster as default as ArcGIS Pro has suggested. Now for the output measurement, remember we have seen from the documentation that you can have it in degrees or percentage rise. So let's just say we are using degrees. For your practice, you can run through the both methods to see how they both appear, right? Good. Now then for the method as well, we saw planar and geodesic, right? Good. Now planar should be for smaller areas and then geodesic should be for larger areas, right? Good. So now this is just a part of geodesy. So now if we are leaving it as planar and then we are also leaving it as degrees, then the Z factor, which we have explained hitherto, to be left as 1, because our X and Y units are in meters, right? Good. So the Z factor should be 1, so we can just decide to run. Good. We have an output. We can decide to dock this back. Good. We have an output that defines what the slope, right? Good. Now remember the output measurement, we use degrees, which means our slope will range from 0 to 90 degrees, right? Good. So we can still come up to the slope raster that is out, the output, and then maybe work on the symbology, right? Good. Now the method, okay, let's still float this, prefer it being float. Now we are classifying, right? Good. So we can decide to use unique values or any other method of what symbology, right? Good. Then for the method, manual interval or equal interval, right? Good. So then for the classes, we can decide to increase or reduce. So I'll prefer to make it about 5 classes, right? Good. So if we add that, we can now also change what the color scheme to something of our preference. So if we want to scroll through the available schemes, then I just like using, okay, is it precipitation? Just like using this color scheme. Good. So we have something like this. So from red up to blue, and then if we now try to bring it down a bit, we are going to see the output. Okay, can decide to take this out so that we can have only our slope. So it defines the degree of steepness, right? Good. So that slope, let's see if we can have that definition somewhere. Okay, the tool identifies the steepness of each cell of a raster surface. So the degree of steepness of each cell of a raster surface. So the interpretation we have here, the result we have here gives us what different degrees of steepness from 0 up to 90, because we have used degree. And then if you use percentage or percent rise, you are also going to have different values, but still defining the same terrain. Also, if the method, perhaps you have a larger scale or maybe a larger area to cover, and then you decide to use geodesic, you can also have different results. So we have shown you using ArcGIS Pro how to show slope in GIS. Right, good. So alongside the documentation from ArcGIS Pro, which when you read would give you a better perspective of this tool, we are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.